Welcome back, guys. On the week, okay. So this week, let's just see what we were doing last week and get a reminder of what's going on. Okay. I guess somewhere here. So we need a physical location to store the user page table, and we have two user processes, maybe hardcore address. We need to map the user space into some physical address. And to keep track of the address, maybe just use, I guess I just wrote it out of just a general overview of it. So these are the steps that we have completed. We have to update all the places with table register to save and restore. We have updated, I guess. We have added some helpers to convert the user maps. Now it compiles. Now we have to make it work next week. So I guess it compiles, but I'm not sure if it works. So what exactly did we compile last week? So the overview is today we're trying to get the MMU switch walk, because the base table switch walk, because currently my k-main, once when I get into the k-main, I have this function that is the first user enter that's just going to take a context, and it's going to restore everything it into the registers and jump into the ELR. So we are switching from EL1 to EL0, and the switch works, but the moment we switch, we try to access the stack pointer, and the stack pointer was pointing to some x 0x fff something address, and that was the first error. We fixed that. And the second error, I believe, was we were using kmalloc to initialize our user stack. Yeah, this was the issue. We initially just called kmalloc for user stack, but if we were to do that, then that would also be in 0xFFF error, FFF address, and accessing that from EL0 would just cause an seg fault. I guess I got an data access fault. The code was 4F. That's how I remembered. I'm not sure. But once that is done, I guess what I did to fix that was that I still use kmalloc to get the address. Now I just map it to, I convert it into a user. It's just identity mapping. I convert it into a similar usable range, just zeros in the front. And then I map that into the user space, this particular processes table. So I create tables for every process. And where is that table code? Map user to physical ID in entering. What does it do? Yeah, so currently I guess we only have two tables because we only have two processes. So if the ID is equal to, we use this address as the table, and the ID is that we use that address plus 6,000. I'm not sure why I added 6,000. Yeah, it's because I have 4 levels of tables and every table needs 1000x in hex. So I guess I have added 6,000, and I can just calculate it like this. The first L1 table will be 0x 100, 1,000, and we just keep adding. And now we update, so we just add the table entries in every level. We find the index in for the level 0, level 1, level 2, and level 3. because we go up to level 3 because our um, Kmerlock stores or keep tracks of memory in terms of 4 KB. So we have to make the L3 changes. Previously we had some issues. I was making block descriptor in L2, that was working fine, but I'm keeping track of things in page and using 2 MB blocks was conflicting with each other, so I had to use the L3 tables. Now things are working fine. I guess think this implementation should just work, because that was the issue that I remember last week we had. That is to There's the access fault, and right now because we have changed both of them into user accessible things, I think everything should just work. Maybe this week we might have to today we might have to debug things around after the switch. Do we have all the registers, because this is my context and I'm saving the 31 registers, this SPL, ELR, the return pointer, and the special registers again. And I also currently store the actual table register, the physical table pointer, or the physical, how do I put it? Where is it? Yep, this register TDBR0EL1 register. I guess someone asked me why I did not, why I named that as this variable as like this. I guess I just named it as the exact register name. I did not recall it at that time. I believe now it makes sense, because I'm just storing this register, so I just named, maybe I have to put maybe underscore reg. That would make sense. Yeah, better sense. I don't know, I just copied this name in small case, I believe. And as you can see, I think we'll have to do something about it, because we have to do something about it, because in normally both the registers are just pointing to my EL1 table, and that's the issue, because if you're trying to access something from EL0 that starts with FFFF, I think it's not possible, and we would get the access faults, and it makes sense. But I think in this case it's just fine, because every time we get into a processee, we would have a context, and that context would be replaced into every register, and when we come out of that user process, the next user's values will be updated on it. Now I have a question. So let's say we have initially like MMU's default registers v1s, then we switch to process 1, and probably if we come into scheduler's code, what registers will be there? I think we'll store the existing ones, and we jump. In that case, would this, yeah, I guess in my context, I don't even touch TTBR1, so that page table entry is same for everyone. So I think that's not an issue, because my idea was like, if there are some default registers here and we switch back to process 1, and when we come back to scheduler, we might need some registers here, that are here to get this execution properly done, but I believe this is the main one. I mean, this would be the main one, and we have it there already. We don't even touch it, so maybe it's just fine. And it seems to be working, so we can just forget about it. Okay. Sometimes I also have to be worried that my screen is getting stuck. I'm not sure why. OBS sometimes just decides to get stuck. I have no clue why. Okay, so let's get started and let's just run things and see what's the oh my god, fuck me. Okay, what we running? Let's just run bash build. What? Terminating? Okay, that's just I'm just killing the previous processes, I guess. I have something here on top. Yeah, I just call pickle cameo, and somehow there was a process that was running with cameo. Maybe it was just the old code that was running. Yeah, I clean up stuff and then I pickle and then I just run the compilation and then I start things in GDB. That's all I do. And if I want to stop here, I just put this exit, which is not a valid statement, so I would get an error there. And that's how I've been managing things lately. What is this? Yeah, I also try to do it like this to start the Camus in background and store the PID and then attach to it. This did not work. I guess this did not work because I was never able to properly send this to background. It still had the same standard out. We have to change this to something like this. Maybe I have just put this. I just put I change standard output. What is standard output? 0. 0 is standard in. No, 1 is standard in, I guess. 2 is standard on. Yeah, it's something. If we can just redirect things, maybe I can make this work. But so far it's just working, so I don't care. I just started that, and every logs will be thrown into the whatever TTY that is currently running as the standard out. So I get both the logs. Do I get the both logs? No, I don't remember. What exactly am I doing here? I'm starting Camo in background and attaching to it. I also put a break in starts and set the architecture to this. Okay, whatever. Okay, so let's just start it. Oh my god, did I just do the same thing again? Okay, so it is the first compilation just works. Okay, so let's just run it. So we jump into task 1 and then things don't seem to be moving forward, at least not based on the looks of it. So let's just get camel logs and I guess log 1. What do we need? We need all fars and AI FAR. Okay, so we do have far, and let's just go to the heads. Okay, we tried to access 0 first of all. That was the initial error. And then probably this is just my vector table. And I don't know why my vector table also gets an error. But why the fuck did I access 0x0? That would be the first question. So let's try to let's just remove this file, because sometimes it just piles up and fucks with my entire system. Okay, let's build it. Now let's start somewhere. Disassemble, use a process. There's no such thing. Why? There must be one user process. Then how the fuck did that tab complete work? If it wasn't there, okay. Tab complete worked because there's one or two, okay. In the current step, there's no MMU enabled, so I'm able to access this. What was that sound? Okay. I guess someone is drilling something. From kernel perspective, we'll have the page table entries for EL1. So this should be accessible because I have some identity mapping, and we jump into FFF as virtual. Even there we have records, so we should be able to access it from EL1 to. What about EL0? From EL0, do I have mappings for this particular location? That's a good question that I need to answer myself, because where do I build that? I think user to physical. I think I'm currently just adding map for the user stack. What is this? And for entry point. Okay, I am adding entry point, and I have a comment here. So entry point is the actual, probably this starting, this is the entry point for this function. So if I'm jumping into this function, I'm adding a entry for that. And my fucking point was that if this is beyond 4 KB, then we might have to add 2 or 3 page table entries per function. But currently it's just too small, so I think just adding top of that entry should be enough, because it will anyway take 4 KB block. So we should be able to access this if my page tables actually work. Let's try to put a break statement here. My fucking yank. Nope, did not work. After jumping into task, something is happening. So let's just see. Let's just stop somewhere here. Let's just stop. First user enter. I think first user enter is it wasn't mangled by the compiler. Yeah, because it's assembly code. Sometimes my compiler just will decide to think that do that. I don't need this fucking function at all. I'll do things faster, something like that, because previously I was debugging something like that in the beginning, and the end result was that compiler decided to remove that entire function and convert it into just instructions. So I was never able to break there. So let me just take this and put a break statement here. But from kernel point of view, we will be accessing it in FFF. Yes, so we are inside the first. Okay, so we are moving SP. What is happening here is this code. Where is my freaking vector dot? Yes, it's here. So this is a simple function. We move when we call this function, we just move the first argument into stack and we restore under it. That is just simply take everything from top of the stack and put things into place, and finally it, so that we can set up things for this processes and get into the processes. Okay, let's try. Let's see which intersection is fucking with us. Probably because my stack is not aligned or something like that. Okay, this is all the registers. And I think we are at the end. Next intersection is supposed to be ERIT. What is SPSP AD? Yeah, that's just okay, wait a minute. We are moving, but those are actual pointers, not values in registers, so it's not like a lifetime issue. Okay, let's see what happens after this reread. Ah, fuck me, I should have checked what was in that register. Let's just check what was in that ERIT. Okay, now let's just put in for register EL. What is that? It's ELR EL1. What? There's no ELR EL1? Where do I write it? I am writing it into ELR EL1. Then there should be ELR EL1. Let me find that. Or maybe it's case sensitive. See, my ELR EL1 is pointing to 0. Fuck me. Wait. Disassemble. There's no stack frame to find the disassemble. We just have to make use of break statements. So it's a stack pointer issue. So let's just figure that out. And let's just break here and continue. And let's just check the x0 first of all. I think we can take a pointer and what's that? Cast it in C++, I mean in GDB. How do we cast a pointer into a struct? And first of all, do we have the context struct? Okay. Sorry guys. I'm sure it's going to be annoying today. Someone is drilling. Okay, let's just see what's in x0 first of all. x0. x0 is pointing to this address. And if we examine 10x of that, it's just full of zeros. Maybe put 50x. One more thing. We are taking a pointer and putting it into the stack. And we are using this operation to figure out the locations. So that is, in this particular case, SP plus this many bytes would be the location of TLB or EL1, and the size is 31 into 8. That is fine. What if I do if we go beyond below that, we don't have page table entries. What if we just put 1000? Even that, nothing is there, it's just zeros. Just zeros, full of zeros. Wait, first of all. What the fuck am I doing? Currently we are moving x0 to SP. Why am I moving the pointer within x0 into stack pointer? That means I'm moving the stack pointer to that location. I'm not even saving that stack pointer. Okay, we can think about that issue later, but let's just say we have this. So first of all, let's just one step into that. Now we can do the same thing again. Let's see, 4 registers SP, and we are in that location. And now we have to move, but that's exactly what I did here. Maybe because it's 8, we are getting 31 zeros. Let's just try 500. Okay, we do have something in the end. So probably these are the registers, and they are supposed to be empty, I believe, because we are entering into a new function. So I don't think it has anything. And then we do have some things. Let's just put 150, 250, 200. Okay, yeah. And then we have this location. Now we try to get something from SP into X1, and this location is 31 into 8. That is my TTB. What is 31 into 8 in hex? Okay, it's here, 248. F8. So I think we are trying to get x plus 0x f8. Okay, we have something in it. It's C000600, and that's my TLB EL1, TTBR EL1, and I guess that's my page table entry. But let's just check if the value is correct. And as I mentioned, I was using some hard-coded address for my users tables, and it is supposed to be here somewhere. Let's just come here and okay, it's here. Let's just see. My user table is supposed to be in 800F00, probably after 100 and something. No, the table value should be this or this. Maybe adding 600 to this value would give no, that would not give that. That should be beyond that. What's this? Now I have some issues with what is here. It's only in Camo, so it's not a hard-coded location. Somehow my what is it? Where is it? Where is it? Where is it? Vectors. It's here. Save and restore. Okay, restore here. So my TTBR0EL1 is pointing to this value. I think because it's saying it showing it in 8-bit or 16 or 32, that's why but we can maybe put 2x, then we would get both the things. I think these two are combined to be the 64-bit value. But still it's wrong, right? Because I should have the actual physical address here. Okay, that's the first issue. What about the next one? Let's just see. 33 into 8, that is what we need to. There's no point in checking that because everything else is just zeros. There's only one we have. Oh, we have this 8000F here. So that is our page table. So it's just my calculation that is fucked up here. And that where we reach here, let's say these, I don't know if these two are 64 bits or this two will be considered 64. How to change the representation to 64-bit, we can check that online. And then we have some 8090. Let's check if 8090 is the entry point. Okay, screen is not stuck. And let's check instructions. Okay, so that is the user process one. So we have stored things properly. It's just our calculation seems to be wrong. Why did it go wrong? Because we added a new thing there. That is our TLTTBREL10. I don't know, man. Seems like it was valid because stack is going from bottom to top. So if my stack pointer is in the top, I should go below. That's why things are placed from bottom to top. So the structure's final field is in the top, and then we just go below, and finally we have the registers. Then why the hell? Okay, let's just check the difference, then we would know. What is it? Everything is D, E, and F. Okay. And what was the top of our stack? It was EE00. And it's here. And the top of the stack has zeros. And when we try to restore, we use these indices, and these indices are actually multiples of 8, and we are taking the 31st multiple of 8. That would be the end of the buffer. Maybe that's the issue. I have to put 34 here, 33 here, 32 2 here and 31 here. Let's just try that. But it was fucking working till this day, so I don't know if this is the issue. We need to break at something. Okay, let's just pick here. Let's just try. No, not this location. No, first I need the stack pointer. Stack pointer is still pointing at 0. And currently mine is 34 into 8. What is 34 into 8? 8. 272. It's 110. Why is hex 110? Okay. Whatever. 110. Let's just add 10. Okay, now it's correct. Because TLB0 is pointing to 0xFFF0. But I wonder why it was working previously. I mean, I had this context code for a long time. Only recently, only yesterday, last week I added this one extra register. And why the fuck should I change the entire layout for that? That does not make any sense. Maybe these 2 registers never actually worked. Oh no, I'm using it between even interrupt handlers, so if it did not work, when I switch, something must have crashed. See, first of all, let's see if it works. Nope, it does not work. Let's just check for. Now we are trying to read F0. That's interesting. Let's see. Looks like something is playing with us. Let's put it here. It's playing. Let's just try to. There we go. Fucking one. Okay, 0x8ff. So it is definitely valid. TLB is fine. What about SP1? SP1 is pointing to 0. Okay, that's fine. I think there's nothing there, so it's pointing to 0. What about EL or EL1? That's pointing to our process perfectly fine. That's good too. And then we have SPR. That is pointing to some value, I believe. Why do we need this value? I guess I set it to some default. Okay, that's why we have that. Yeah, we set it like this. I don't fucking remember what that is, but yeah, 6 is moved to some bit That's why we are shifting 6 into some bit. Okay, fine, that's fine. And then we just shift all the pointers, and then we, what is this? SP 0018. Yeah, that's just to bring back the stack. Okay. And then we get into 4 registers. Real one was correct. And TT BRL1 BR1 TTBR0, yeah, that is also correct. So now it's just a page table. Our page table fucked up. We are trying to reach this processes with this page, the new page table that we have, or at least the new page table location that we have given, and MMU tries to read things from that table, and we don't have an entry for this. But for fucking God's sake, I just added it. Why the fuck is it not working? So what the fuck is entry? Entry is supposed to be the actual entry is the pointer to the user process. So that is the initial address of the function, and I'm using that as a use64 value, and I'm adding a mapped entry for it. Okay. My fucking question would be, okay, let's check which let's just check which kernel simple MMU C8 kernel 1. We need farce, all farce, and the heads, and I need 5 lines. There's no fucking far. What the fuck? We have reached the far. Okay, so what the fuck is in the end? Tail. Okay, I should not put cat and then tail. It would be fucking annoying. Just put tail. Let's put 250. I guess 250. Looks like there is no false. Then why the fuck it is not working? Also, GDB is not able to get that location either. Oh, maybe the page table entry works, but the page table entry actually does not have anything there. Okay, let's see if we can access 8000. We're not able to access 8000 either. Let's try to access what else? What other page table entry did we add? We also added the stack, so let's try ESP. ESP is pointing to F0E. What the fuck? Wait. So something is wrong with my code. I get the where's it? I get the stack, kernel to user space. This function is supposed to take the virtual address and AND it with 0 FFFFFFFFF. That should zero the top bits and keep everything else as it is. That was my assumption. Maybe I fucked up in this line. Okay, let's check this. Let's check this use stack value. Oh fuck me. As use stack. If we go a little back, scroll. We have one use stack here. Now we have the other use stack here. Let's just check. Just email to hex. What? Why do we have this value? I mean, it makes sense because my entire kernel Camelot starts from C, so that's fine. That's just fine. So when I actually add it here, it did have a valid user stack address, but the moment we jump into that, we have the value wrong. Wait. No, it's still running. What the fuck is wrong? Wait, where do we set the stack pointer? We say user stack is here, and we give it. Oh, we don't save user stack anywhere. Maybe that's the issue. No, we do save it. It's here. And when we try to schedule a task, we return a context and we enqueue it. But in this particular case, when I first jump into this function, I I only pass a context, and that context does not have a stack pointer. Maybe that is the issue. Because let's say I enter into this, stack pointer would not change, because unless we update it, who the fuck would change that? Because we can't leave. What is the stack pointer? The stack pointer is somewhere here, and if we keep going, and finally we just add sp to sp, and just when we do erit, sp is still this, and erit is not going to magically update. It's not just going to magically update my stack pointer, is it? I don't think it would do that. So yeah, maybe this is the issue. I'm supposed to somehow save the stack pointer too, but why the fuck do I have a task struct then? The task struct is supposed to. When I switch between two processes, okay, when I switch between two processes, I'm also supposed to save the stack pointer. If not, because even my switching is just my switching is just written, it's just going to return a current context, so it does not really, whatever is in the context is going to be saved and restored, nothing else. Okay. So I get the gist of what is the issue I'm working on. So okay, currently now we somehow fix the what's that, struct manual indexing error, indexing issue, that is our what's the indexes within the struct was not correct. CCD updated that, but now if we think about all the things that are needed to completely switch from one process to another, stack pointers don't magically get switched. We need to store and restore this too. I guess previously I was using the same stack between all the processes. Yeah. No, I did not do that. I did have a separate stack pointer. Something, I'm missing something. I believe I thought about this somewhere and I did have. That's the whole point of having this fucking user stack and kernel stack. And but where in I have stored it, but when I'm actually switching, when I'm actually switching, there's no updates. I think I just move the task kernel stack. Kernel stack is the same. No, this is also different because kernel stack holds the context. The entire context is placed inside the kernel stack. Mm-hmm. Okay, so I have to move. Okay, so now the to do is just to move the kernel stack and the user stack into context and switch them. So what is my task supposed to do? I don't know. What does my task do? What's the point of my task struct? Where the fuck is my task struct first of all? Okay, it's inside scheduler. It has ID, context, user stack, and kernel stack. I think I just have to move this user stack and kernel stack into context. That would be the best case. Am I using this anywhere else? Not really. Only inside init function we use this. Even the user stack, I don't believe we use it anywhere. And oh fuck me, SPEL1 is the stack pointer. Yeah, now the guy who mentioned that I need to have better namings for the variable makes sense to me. I just confused my own variable naming. This is the stack pointer, and I did think about it. Yeah, I was thinking about it because I need to restore it. So it makes sense to restore it. So only thing I have to add is the kernel stack inside this. But I need to check one more thing. I also need to confirm where the fuck am I ESPEL1 and where am I switching it? I take this is save context. And what is SPEL1 EL0? What the fuck is this? Is that a register like SPEL0? SPEL0. What's that register? But why? How come I'm just able to take it like this? Just SP. What is SPEL0? It says there's no such fucking register. Hmm. So does that mean if I automatically put the value inside SPEL0, it would put that there? Something like that? I don't know. Right? First of all, where are we? We came out of that. I mean, I could just simply put things into SP and make this work, but I just want to understand what the fuck is ESP, EL1, REL0. That's what got me confused. I thought it's some special register. I'm just storing it and restoring it back. Because specifically, we are currently just taking the SP, so we will never be able to update the SP here, because if we update the SP here, we would or we won't be able to use this here. Maybe I can just move it to some other register and have it used here. Or maybe I can update it in the end. I can do either. Wait, let's see. And it's a special register because we are trying to read it with. Maybe we'll just ask. SP versus SP. Okay. Okay. This is only used for exception handling. I didn't fucking get it still. Okay, I did not understand anything. Holds a stack associated data and something else. Fuck me. Okay, so each exception level has a dedicated stack pointer. So the purpose of is to allow the software to configure the choose which SP register and where can one be used when an instruction referred to SP while the CPU is L1 shown. Okay, it's like an alias, and based on the actual current level, it can either point to L1 or other things. So it's like you can just write the code as SP, and based on the current level, it will switch to ESP L0 or SP L1. Okay, fuck me. Shit. Okay. Okay, that's something new. So SP is just alias, and SPL zeros, and those are the actual registers. And based on the uh, exception level, it can be switched between any of them. Okay, and I do believe I added some fucking thing like that in the front. Maybe that is what is fucking with me now. Okay, yes, I'm setting SPL to fucking 1. What does that mean? If it's set to 1, then it would. What is it? If it is set to 0, it will just select SPLEL0, and when it is set to 1, it can choose based on the exception level. It can be anything. It can be L1, L2, or L3. Okay. And I always set it to 1, so I'm fucked that way. So even when I get into EL0, maybe I don't need to set this at all. If I don't set this, what would happen? Okay, now we have an actual exception, and it's no, I have to go to Fahrenheit. Alright, this is the exception, and it's still the same fucking F0. And that's possibly because I'm using the SP there. But if I set this here to, if I don't set anything inside EL, when I'm inside exception level 0, it should automatically use SPL10, right? My question is, we are inside EL0, we are inside EL1, and we are in some random SP, and when we ERIT is supposed to actually also make it switch the SP. No, in general, SP is an alias, and if I think we can just switch, set it to 0, and based on the exception level, it will automatically choose whichever. Where is it? Where's my fucking start.s? Okay, I'll just put 0. Oh, not that. Okay. Okay, now we have a different error. Now we have the same error, but at least it looks like a valid pointer, or at least little better valid pointer. Okay. I don't know. I guess it's time to write things down and think about it tomorrow. So SP is just an alias to SPEL Yux, and based on the EL, this alias will be pointing to the correct physical register. Now let's just I guess this is the only thing we learned today. Let's just save both kernel and use a stack. I mean, like, if I save the kernel stack, what exactly is the point? Because I cannot. Okay, I can save it inside EL1. Okay. And pop them into EL SP EL0 and SP EL1, and then confirm if we switch from EL1 into EL0, the alias of SP is pointing to the EL0 correctly. Or do we have to update the state pointer before it? Something like that. I don't know. These are just questions I have in my mind. But in general, at least today we were able to learn something new. That is to say, at least I didn't know this, but because somehow um, I remember something like this, but I did not know the exact thing because now it makes sense because we have multiple EL levels and almost every code is just going to have SP. That's why I mean, like, that's how my entire thought process is. SP stack pointer, and I was thinking like for every level we have to update the stack pointer, but ARM has a better way to do it. We just have physical registers and one alias, and every code can have this alias, and that alias will point to the proper physical pointer. This makes sense and it's just so fucking amazing they came up with this idea, because in my mind it just did not come up at all, because I was just thinking I have to update the pointer every time in different EL levels, and it can be automatically done by ARM. We just have to update the physical register and just have one SP which is gonna point to whatever EL it is, and it's just so amazing. And it's this state pointers, this. Okay, let's just think about it tomorrow. I think I have mostly done theory today, so that's enough, because and I have done only debugging today, mostly just debugging and a little bit of theory, so that should be enough for today. Thank you guys. Bye bye.